and work with STM3 to F4 ARM Cortex M4 based kit. Mr. Darji guided more than 10 projects for UG, PG, and PhD programs. He delivered lectures at different short-term training programs, faculty development programs, and conducted seminar, training, and workshops on embedded hardware at various educational institutions in the country. I would like to request Mr. Bhavin Darji to start his session. Over to Mr. Darji. Sir, please.
Thank you, sir. Thank you for introduction. Namaskar, everyone. Myself, Bhavin Darji. I hope I'm audible to everyone, right?
Yes, sir. You are
Yes, sir.
audible.
Yes, sir.
Okay, thank you. So, first of all, I will share my screen so that I can give you some of the idea like what I'm going to present or what I'm going to do. Okay, so entire screen and start. So I think now my screen is visible to everyone, right? So here I will open this PPT and now I think the screen is visible to everyone, right? Hello.
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
Okay, okay, thank you. So
Yes, sir.
myself Bhavin Darji, and I am from EduTech Learning Solution. So before I start the actual session, which is introduction on quantum AI, first of all, I want to give a brief idea what EduTech Learning Solution do. Okay, so as the name suggests, as you can see in the name, you can see learning solution. So basically, we provide learning solution which includes hardware as well as software. Okay, both kind of solution we provide and to the educational institutes, which includes IIT, NITs, government colleges, private colleges, all kind of institutes provide. We provide solution. Okay, so we started with a very basic microcontroller. We usually provide solutions to the electronics and communication branch stream as well as computer and IT stream. So we started with electronics, which is like 8051 microcontroller, which is very starting point for you can say like learning the electronics, right? So we started from there. So here you can see some of the component. So initially you might have seen the 8051 microcontroller with some big IC with 40 legs, right? So we started from that microcontroller and now we are using this microcontroller. This is also 8051 with industrial grade CPU. So you can see this is small, this small IC is basically 8051, and using this we have all kind of peripherals. You can even debug the program and all different features available in this microcontroller. So now we have shifted from that typical or classical 8051 to this micro 8051. Apart from that, then after we started with the peak microcontroller and AVR, so we also have this platform for learning the different architectures. And then after, as the technology changed, we also added different microcontrollers which include 16-bit. Previously, it was 8-bit microcontroller. Now this is the 16-bit microcontroller, which is based on TI platform. Okay, so this is the TI microcontroller chip, which is very low, ultra low power chip available in the market, which is this one. And then after, by the time newer architecture came into the market, which is based on ARM, I think everybody is aware of ARM technologies because in our current mobile phones as well as different embedded platforms, they are using ARM architecture for creating the processors. So based on that, the same ARM architecture, we are using ARM 7 based microcontroller as well as ARM Cortex M4 based microcontroller and ARM Cortex M0 Plus based microcontroller, which is basically made for IoT. Okay, so using these different platforms, we have created different labs. So hardware plus software. So that lab includes different solution that I will go into the next part. Apart from the microcontroller, in electronics, we also have a subject like digital signal processing. and we usually do with the MATLAB, right? So that is basically simulation, and we wanted to do that the same thing on the actual hardware. So how we can do that? So for that purpose, we have explored some TI-based microprocessors. So here, this is the TI 5000 series processor. This is 6000 series processor, and this is 2000 series processor. Okay, so these three different architectures are there, and this processor basically provides signals and you can say audio and signal processing with very basic, with very limited feature. And to for the higher end purpose, we also have this kit 6000 series. So this additional to 5000 series, it has floating point support, as well as you can process image and video processing. So you can perform all different kind of tasks like basic. You can perform all basic image signal processing, video processing. You can do all things in this platform. Okay, and apart from that, we also have 2000 series processor. So this processor is basically used in electronics, sorry, electrical power electronics side. So suppose you wanted to work with three phase or one single phase induction motor, something like that, then you can use this platform. Okay, apart from this platform, we also have this embedded kit, which is based on ARM 9 architecture. So it started when around 2008, it started the Android platform came into our mobile phones. So mobile phones are basically embedded system. So how that Linux-based Android system is deployed on this embedded platform, I know it is with UI, but how it is deployed. So to understand this concept, we have created this lab in which we are trying to deploy. We are deploying Linux architecture, Linux OS in this embedded platform. So how it is implemented, how it is modified, how you are modifying the kernel, how you are modifying the file system, how you are writing the boot driver. So everything you can learn through this platform. And these are some of the kits nowadays. These kits are quite famous, which is from NVIDIA, which is Jetson-based platform, which is used for the deployment of AI. I mean, machine learning and deep learning trained models. So basically, when we are training a model in AI, so after training, what will be the application of that model? So basically, as we know, in our mobile phones, we are using different applications like cameras, AI cameras. So when you are trying to capture certain scenery, so it will automatically identify as a either nature, or if you are capturing some food, it will automatically set the parameter according to the food. And so this is basically AI. It is trained on some high-end computer, and then after it is deployed on your mobile phone. Similarly, this is also the similar kit which can perform certain tasks, which includes AI-based inference, as well as you can learn parallel programming. I will come to that point. Parallel programming will come in next future slide. And some like image you can image processing, you can use OpenCV for image processing, OpenGL for image rendering, then Vulkan library is for also hardware accelerated image rendering. So this kind of libraries can be implemented on this kit. So there are vast different kind of application you can create, as well as you can use this hardware in robotics also. So suppose you in future you are planning to create some AI based robot. You can think of like a self-driving car or robotic arm, just like that in Iron Man movie, we have seen Jarvis, right? Similar kind of system you want to create, you can use this kind of platform to deploy certain application. Okay, so and where you are going to train that model, so we also have solution for that. I will skip this part, and these are the lab. So here you can see these labs are basically for microcontroller. So in this basic lab, you will understand all the feature of microcontroller, and using based on that understanding, we have created another lab which includes IoT, which is artificial intelligence, AIoT. Then RTOS lab, you can learn how FreeRTOS or MuCOS2 is implemented on microcontroller. And then after sensor lab for understanding of different sensor, how it is interfacing with the microcontroller and how it is performing. Okay, then after DSP lab and then other lab based on that AI as well as image video processing, embedded Linux, and all these things. So this is the basic portfolio that we have. And now we will shift to our current main topic, which is completely unrelated to this existing setup, which is the quantum AI. So, first of all, in quantum AI, as you can see, I will first what I will do, I will separate these two parts. So basically, here first we have to understand how AI works, and then how it can be implemented on quantum computer. Okay, so first I will try to explain what AI is. So I will start with what is AI. Okay, then after next step will be the how it can be how it is implemented, which is you can compare with human brain, right? Then after to implement in a way, such a way like create artificial intelligence, we are implementing uh, uh, brain network, right? Which is neural network, right? So how it is how neural network is created, how and then after we will understand how it is implemented on CPU as well as CPU plus GPU system. Okay, that is the important part. So you will get the basic idea of how AI is working in traditional computer, traditional or classical computer. Which is compared to quantum computer, we are using classical computer. So we will understand how these things work. And after that, we will start with quantum computer, which is this one. First, we will try to understand what quantum computer is, why we require quantum computer. Then after we will try to understand the concept of like basic funda behind the scene, what we are exactly doing. So some basic funda will be included, and what is the application, which is I think everybody is aware of, right? What is the application of quantum computing, as well as then after we will try to understand how we will try to compare with our classical computer. So again, versus classical, and then after our last point will be the AI, how AI can be implemented. Because right now quantum computer is a very initial state. So even in till August 2025, they are still working on error correction kind of algorithm and all these things they are working on. So still we can't consider quantum computer is a replacement of our classical computer, which is our normal computer. But it can be incorporated with our current setup so that we can utilize the feature of faster execution. Right now, we are using in our normal computer, we are using CPU only. But if we include GPU, we will get better performance, right? Similarly, when we are using quantum computer with our traditional classical computer, we will get better. We will get better result. We will get faster result. So that is the main difference. Okay, so this is the current scenario. This is the points that we are going to discuss in today's session. Okay, so first, I will start with the AI part. So, what is AI? So, basically, let's take a robot. Suppose you wanted to implement AI on a robot. So, basically, how you are going to do that, and what is the meaning of AI? So, it is, as we know, it is basically artificial intelligence, and we wanted to create a device or a robot which can make certain decision just like human brain. So that is the idea behind creating AI. Okay, so to I think it was initiated in 1960. I don't exactly remember, but it was something like that. They have started in that era, but they don't have certain kind of hardware that we have actually right now, as well as the data storing, as well as data creating techniques, as well as devices right now that we have. On that time, it was quite difficult. So because of that limitation, it was not initiated this much earlier, but now it is possible because of the technology. Okay, so So basically, what we are doing is we are trying to create a replication, like how our brain is working. So our in our brain we have neurons, right? Neurons. So neurons are created something like there are multiple neurons in our system, and all neurons are connected to some other way, like something like that. It is creating a network, right? So this network is basically called neural network, which is the basic funda of creating artificial neural network. So that is the main part of artificial neural network. Initially, this circle are called perceptron in language of AI, but nowadays it is called neurons, artificial neurons, because in perceptrons it was only processing certain kind of equations, certain mathematical equations, but nowadays we are doing so many different things in the models. So basically, a neural network in other language we are calling it model. So when we are saying like training a model, so we are basically training a neural network. Okay, so this is how the AI, the artificial neural network, come into the picture. And then after, how we are going to use this network to for doing multiple things like image classification, object detection, segmentation, pose estimation. Then after, nowadays we are using it for language, a large language model, as well as we are using for language translation. So there are so many different applications. So can we do simple ANN kind of network to perform all these kind of application? No, as we know, because we are implementing an artificial neural network using mathematical equation. So same equation can't be used with all kind of uh, 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 problems. So that is why what we are doing, we have created different kind of network, neural networks. So some of the neural networks you might have heard, CNN, RNN, you might have heard, right, etc., etc. So in CNN, you may find different models. CNN is basically convolution neural network. RNN is recurrent neural network. So here in RNN neural network, what we are doing is we are basically used for sequential data. Suppose we have some data which is based on text. So to process text-based data, we are basically using RNN kind of network. And when we have some image kind of data for image classification or object detection, we can use convolution neural network. So right now, what I will do, I will take CNN as a, network to explain how we are using convolution neural network or uh, uh, to on CPU as well as CPU, GPU as well as quantum computer. Okay, so this is the way I'm going to explain how we are using it. So why I'm including all this basic part, because for the content which is actually implementation on quantum computer, it is quite less to for long period of speech. So that is why I'm including basic. That is the core part which is required to understand how neural network works, how it is implemented on our classical computer, our computer, and based on that we are trying to implement on the quantum computer. So that is why I am including all this part, as well as the implementation of, as well as the understanding of neural network. Okay, so right now, what I'm going to do, I will select CNN as a basic part to explain all these things. Okay, so here you can see the what CNN is. So CNN is basically convolution neural network, right? So uh, here in this image, you can see there is input. Input is basically image for convolution neural network. Output will be either it will be identify some object or some classification, then it will be some number. Okay, number. So this is how it can be done. But in the intermediate part, what we are doing. So the question is, we all know deep learning. So why it is called deep learning? Because in the intermediate part of any neural network, we are performing certain tasks. Like for let's take an example of convolution neural network. So in the convolution neural network, what we are doing, we are trying to extract feature of certain object. So let's take an example. When we look at a car, how we are identifying it as a car? Because it has four wheels, right? It has a bonnet, it is its body structure, it is quite different compared to auto rickshaw, right? So we can identify what is auto rickshaw and what is car, because we can identify the feature of that object, right? But for the computer, it is only understanding 0 and 1. It is not a computer won't able to identify what is car or what is auto rickshaw, because for image of auto rickshaw as well as for image for car, the both will be the 0 and 1 only for computer. So how it can be done? So for that purpose, we are implementing different mathematical equation that will be used to extract feature of certain image, and that feature will be used to identify certain parts of certain objects of that image, and based on that identification, it will identify the output. Okay, so this is how the whole process go. And here in the image, I'm only showing two hidden layers, these two, but in normally you will find multiple hidden layers. So based on this many layers, it is called deep neural network, and that is why it is called deep learning. Okay, so this is how we are identifying the hidden layers. But the problem is, normally when we are performing some deep learning based experiment, we are not able to execute this we are not able to understand how this is being processed, how, like in this block, what exactly happening, what mathematical equation is applied, and how it is performing. We are not able to see all these things. So to do that, what we are going to do, we have certain website or certain algorithms which can use to monitor all these things. So suppose you wanted to understand what is happening behind the hidden layer, then you can use certain website, like I will share this link and all these things to understand all this understand this part. Okay, so this is how it will be executed in deep learning or deep neural network. Okay, so next part, for the explanation purpose, I'm going to take MNIST, which is basically MNIST is basically, here you can see digit classification. So suppose you are giving certain image which is written, handwritten digits is there, like 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, suppose you are giving this kind of data in form of image. So that model can that MNIST data set will be used as will provide this kind of data, and then our CNN model will use to identify the digit from that image, and it will give us the output, like what this image is. So here for the sample, I am showing you one image. This is for 7, and the size of this image is 28 by 28. Here you can see this image is basically black and white. So the channel will be the one, because we are using uh, a grayscale image, right? But suppose you have colorful image, then the size will be like, suppose the same size we are using, then 28 by 28 by 3. The 3 will represent color RGB. So basically, your image right now, this image is single image, but if we are adding color, then it will become three different images. Like for R is this one, for G, and for B. So there will be three images that we are going to process. Okay, so this is how we are processing the data. Okay, so for the reference, let me just clear this out. Okay, so this is how we are going to process the data. So here for the example, I'm using MNIX. Here you can see the name as well as which model we are using. So this is under CNN. So we are using LANET 5. 5 is for the how many layers are there. That is why LANET 5 is mentioned here over here. So When we think, as I told you previously, that we have certain layer, this is input layer, then there will be certain layer here. We will perform some mathematical process. Then there is another layer, it will process something else. Then last you will get the output. So here you can see what are the process that we are doing for MNIST data set. So digit recognition example. So here you can see I am using this digit 7 as an input. So what will happen when I give this input, the image as an input, it will identify the image. What is the size of the image? You can see over here, right? Grayscale. And then after, first of all, what it will do, it will normalize the value, so it can easily process. Why we are doing it, I will explain later, because in the later part we are going to work on CPU and GPU. That is why I will explain that part later. Then after second part, when we are using LANet, it in the second layer, which is convolution one. So in convolution one layer, it will apply 32 different filters. The size of the filter is 3 by 3 matrix, and stride is 1. So it will move each column and row. Then after, some activation layer. And this will be your last output. That is 128 by 128 by 32. Why? Because a single image, that is 28 by 28 cross 1, we will apply total 32 different filters. Let's take one filter, suppose 10 minus 1000 to oh sorry, to 1 minus 2, something like that. I have created this matrix 3 by 3, 3 cross 3 matrix. And what I will do, I will use this matrix and apply on this image. So basically on this image, and I will process the output. What I will get, the final result will be considered uh, as a output in the form of same image, but it will be the channel is changed from 128 cross 128 cross 1 to 128 cross 128 cross 32, because now we have 32 different images, so 32 different processes. That is why now it is changed to this level. Okay, so here we are, what we are doing, we are doing matrix multiplication, mat multiplication on using this 3 by 3 matrix on this image. Okay, so that is one part. Okay, after doing that, we are using some pooling layer. So this pooling layer is basically used to decrease the size of the data. Why? So here you can see we are using 2 by 2 matrix max pooling. Max pooling will maximum, it will identify, let's 2 by 2 matrix is there. When we apply 2 by 2 matrix over this image 128 by 128, so it will check which data is maximum, like 1, 4, then after 6, sorry, 8 and 6. So it will combine this 4 pixel into 1 pixel with the size of 8. So this is how it will reduce the size from 128, 28 by 28 to 40 by 14. So this is how it is reducing the size. Sorry, not here, but here. You can see it is size is reduced. But our matrix, sorry, images is the same, 32. Okay. Then after, what is happening? We are applying another convolution layer. Now, I haven't said why we are doing, why we are applying convolution layer. What will happen in first convolution layer? What will happen in second convolution? I haven't said that. But here we are applying 62 filters. So that is like we are applying we are creating different 64 images because using the 62 filters, and then after we will get this response, this many images. Okay. So now, what is the difference between this convolution layer? Sorry, this convolution layer and this convolution layer. So when we apply a mathematical equation on this model, what will happen? So this is the CONV for one. So what will happen when you apply 7 image as an input. First, in the first layer, convolution layer, as I told you, convolution neural network is used for extracting features from the image. So this first layer, it will try to identify using 32 filters, 32 filters, filters. It will try to identify edges like horizontal edges, vertical edges, diagonal edges, this kind of edges it will try to identify from the image. Okay. Then after we are reducing the size using pooling, right? Pool one, it will reduce the size, and because of reduction, it will strengthen the detection feature detection, so that after that it will reduce the load on CPU as well as GPU because of pooling. And then after we are applying again another convolution, CONV1, sorry, 2. So in this convolution layer, what we are doing, we already have edges detected. Using convolution 2, we already have the data in form of edges kind of thing. And after applying again convolution, it will try to detect curves. Like suppose let's take 6. So it will try to identify this loop, or in 8 loop, 9 loop. So it will try to identify different curves. In the 5, you can see this line, but this is curve, right? So this in 3, this kind of, there are curves. So it will try to identify curves is higher level of feature. It will try to identify higher level of feature. Because we are giving lower level of feature as an input to the another convolution function. So this is how we are trying to identify features. So here in the second convolution, we are able to identify curves. So we can identify what these different digits are. We can easily identify. Then after, again, we are reducing the data size by sampling using the pooling. So now the image size will be 7 by 7, which is quite small, so that our CPU as well as GPU, suppose if you are using GPU-based system, then it can perform faster. But suppose you don't have such system, then we are going to use CPU. Then CPU can also perform certain level of task because we are reducing the load from CPU. Okay, so this is how we are reducing the load. And then after, we are converting 2D vector. So our image is in form of 2D 28 by 28. Now we are converting into 1D vector. Here you can see. So our image is total 7 by 7 single image, as well. Such images are 64, right? So we are combining all these images and we are creating single array of 3000, approx 3000 elements. Okay, so this is a single element is created. And then after, we are applying fully connected layer, or you can say dense layer. And using the dense layer, we can apply some neurons based calculation. So it will give us total 28 element of vector using this. This is also mathematical equation. So it will give us certain output in form of very close to our result. And then after, again, we apply last fully connected layer, dense layer with 10 neurons with last softmax activation function. So this function will be used to identify our digit. So our image is 7, right? We are providing 7 as an image, right? So here it will give us the output with probability. So 7 is like 0.95 per 95. So you can say it is 95% 7. So this is how it can identify the image. Okay. So here the next part is the some. Okay, I can copy this text so I can show you. It will be quite better. Copy, and I will, sorry, open browser and paste. So here, this is the website which can give us the visualization. Here you can see. So here 3D visualization as well as 2D visualization. So first I will open 2D visualization, opening in private tab. So here you can see this is the website. So whatever we are doing, this will be our image. Here you can see on the bottom side, that is our image. So suppose I'm giving image, let's take 7. as an image. So here you can see what exactly happening. So on the right hand side here, layer visibility. So in this is the input layer. You can hide, you can see. So here this is a input image. So this is the image. So what will happen when we apply convolution layer? So first, this is the convolution layer, one layer. If I remove, you can see the difference. So in the first layer, you can see it is identifying horizontal, vertical, and diagonal edges. So this is how the first layer is applied. Then we are doing downsampling. That is our pooling layer. So if I hide this, you can see the difference. So this is our pooling layer. Here we are reducing the size of this image. So you can see the actual size is this many pixel. Now it is reduced to this pixel. Okay. Then after we are giving the downsampled image as an input to convolution layer 2. So this is our convolution layer 2. If I zoom in, you can see now it is identifying different kind of edges, not just edges, but different shapes. So based on this data, it will try to identify the object. Okay, now again, second down sampling. So it will reduce the size into this form. So suppose if I wanted to see certain pixel data, so you can see like this. So here, if I keep pressed, you can see the output. Like you can say weighted input. I will explain weighted part later. So how it is calculated and what is the output, your image filter it is providing, everything you can see in the detail. Okay. So and then after we are down, after the second down sampling, we are using fully connected layer. And before fully connected layer, we will convert this data into 1D array. Okay. That is flatten array, layer. And then after we are using fully connected, sorry, fully connected layer. You can see this is the fully connected layer. Okay. And then after using the second fully connected layer, it will generate the output. So here right now it is showing the wrong output. Okay. It is showing the wrong output. As you can see, it is showing 3 as the output, first guess, and the second guess is 9. So here you can see the light different color difference in the color, right? So the 3 as a light color, second light color is 9, then after the 7, third option is the 7. It is detecting as a third option, third, or yes, that is third. So this is how it is identifying the object. So if you change the number, then it will get the different output. Just say let's take 3 as an input. So as it can guess 3 correctly, as you can see as a result. You can change to 5, and you can see 5 is guessed correctly. Same way here you can see as a 5 is the most light color, and you can see the result is 0.92. So in 92%, so 94% it is 5. Okay, so this is how it is identifying each and every part of the image. Okay, similarly, there is also another way to showing you. So that is the another link that I wanted to show. So this both the tools are available on net. Using this link, you can easily download and you can use it on your PC also. So like on the another website, here you can see the actual processing. So how what we are doing, what computer is doing, you can see over here. So first of all, you can see this is the basic idea. This cup is the input image which is in color. So as I told you, the size of the image here you can see this is 64 by 64 by 3, because we are using three colors, which is red channel, green channel, and blue channel. So that is why it is divided into three part. And then after what we are doing, then after we are giving as a convolution layer one. So here you can see convolution one. Here I'm just applying 10 filters. So here you can see the difference. Okay, and you can see the edges, detection of the edge. You can see each and every line. So how this result is, how we are getting this result? To see that, I will scroll down to here. You can see in this. So you can see how filters are applied on the image and how the data is processed. Here you can see again, right? So this is how we are processing the data in the backend side, like what hidden layer, what is happening in the hidden layer, you can see like this. This is how the hidden layer are processing the data. Similarly, you can see convolution here, how each and every pixel is processed in such a way. In the center part, you can see how it is processing and how it is generated in this image. Okay, so this is another way to see the result. And this is, you can change the parameter, like what is the input size. For our case, it is in here it is mentioning like 20 5 by 5. You can change, increase the size 7 by 7. You can change the padding. You can add another layer. So here now you can see the 9 by 9 image is there because I have added one pad from each and every direction. So now it is showing different part. Kernel size is 2 by 2. I can increase 3 by 3. So now the my filter size is 3 by 3. I can process like this. You can see it is moving. Pink color is moving according to the mouse cursor I'm moving. Here you can see this is how it is basically processing in the image. And the stride is basically skipping, like how many image I want to skip. So it, even though first it will take first pixel, then after it will take third pixel, then after it will take fifth pixel, and then last pixel. So this is how it will move. It will skip the uh, even line, even column or row. So the it will reduce the output. So this is how we are downsampling our image in pooling mode, pooling layer. Okay, so this is the second part. So this is the these two links are there. Apart from this link, we also have this YouTube video. In this video, this website is explained very nicely. So right now, I'm not going to play that video. It will take, I think, around 20 minutes. Okay. So now the most important part, like what we have done over here, that is basically called inference. We are not training any model during this process. We are just giving input image and we are processing the out, we are getting the output. We are not trying to train the model. So this is called inference. Okay, similarly the same process I'm going to apply using CPU and GPU. So here you can see, sorry, here you can see how we are processing the GPU. So I am trying to explain each and every layer as you can see over here. So first of all, CPU or CPU GPU process. I think both processes similar because nowadays we the CPU have around hundreds of core, right? Core, and whereas in GPU you will find around 25K core. So basically, 100 core or 25K core, the processing will be this process is similar. We are just the difference is only the performance, like how fast it can perform. Okay, that is the only difference. So basically, right now I'm just trying to show you how it is processing. So we already seen that website. So input layer, this is input layer. This is our image. What it will do? First, it will load this image into RAM, CPU RAM. Here you can see CPU RAM. It will load it. So this basically this array is total of 784 elements, right? So in this array, let me enable the setting. Sorry. Okay. Right. So basically here you can see this is the total one 728 array. So this data will be loaded in the RAM. Then after it will be loaded to the cache memory. So in CPU, we already have know that there is L1, L2, and L3 cache memory, right? L1 is closest to the CPU core, then after L2, and this is L3, which is farthest from the CPU core. Okay, so size of L3 is also quite big. So from the RAM, it will be loaded to L3, then after it will shift to L1, then where it will process the data and it will send back to L3 or directly to RAM. Because it depends upon the size of data, how it will be loaded. Okay, so in the second layer, convolution layer, what we are doing, we are applying 32 filter of this size. 3 cross 3 matrix we are going to apply, which is 32, which is 32 filters. So there are 32 layer. So total number of element we can see there are around 25,000 values are there. So in this first convolution layer, what we are doing, we are basically creating, let me change the color. We are creating around, sorry, this many multiplication. We are doing this many multiplication, approximate, this is approximate number. You can find by calculating it, but it will be around uh, 2 lakh 25,000 multiplication we are doing in just convolution layer one. While doing the convolution layer, what it will generate some weights are basically actual data that will be the result that we are getting. Like when we are training a model, it will generate some weight data. Based on weight data, it can identify the object. It is like the probability you will get. For say one, we are getting like if 0.95, that is 95% is the probability which is based on the weight data. So basically, we are processing this thing. We are getting weight data of for around this many multiplication. It will be stored either in RAM or the internal cache memory, L1, L2, L3, I don't know. So it will be stored somewhere like that. Then after pooling layer will be applied. So in pooling layer, basically we have 2 by 2 matrix. We are not doing anything in pooling layer. We are just trying to downsample this matrix, okay, which is 128 by 28 by 28 by 33, 32, which we are reducing into smaller size. So here you can see we are applying max pooling, which will like uh, compare to for value of region to find the maximum number. So it will try to maximum number as I have shown you previously, and the size will be reduced to this much. And here we our image will be 14 by 14, and we have total 32 image 32 layers, the feature maps in language of this deep learning or neural network. It is called feature map. When we are processing, when we are applying convolution layer, so it will become feature map of 32, total 32 feature maps are generated. And then after, when we apply another convolution layer, which is 62 filters, so the size of image, the filter will be this one, because we are simultaneously applying to each and every feature map, or I can say image, or I can say array. Okay, so and then what it will do, there will be around 12,000 values it will generate. And we are and approximate when we are calculating in this way, which is like 12k into, it will be uh, 787, that is 12k. Then after 3 into 3 into 32, sorry, not 32, 32 into 64. When we apply when we calculate this one, then the multiplication will be in the millions. So this many weights are generated. So you can see how the calculation is going. Right now, the example MNIST is like a hello world kind of example, very small example, which can be easily executed even on CPU. So I'm just giving you approximate idea analogy, like when we are counting 1 to 100, uh, that much time it is CPU is taking to perform the training for this model. Okay, and when you are counting from 1 to 10, that much time will taken by GPU. Okay, so I'm just giving you analogy how much time difference it will create, but still you can perform this application on CPU also. Okay, so you can see how many multiplication we are doing. And then after again, pooling layer 2 will be applied. It will reduce the region, it will reduce the feature map size, and then after we are flattening the image, it will create this many elements. Then after this first fully connected layer will be applied with 128 neurons. So it will again create this many uh, multiplications. Okay. And lastly, when you apply 10 neurons, it will create this many multiplication. So these are all the multiplication is applied when we are doing inference. We are not training here any model. When we are considering model training, then you have to consider another layer, which is propagation as well as weight update. So weight update is basically like error correction, what we are doing, like loss calculation, gradient computation, and using these two things, we are updating the weight value. So what weight we have calculated using multiplication, it will be updated at the backpropagation time in the training. So everything is running simultaneously due to multiple cores available in our CPU as well as GPU. So because of that, it will reduce certain level of time. Okay, but still it will take too much time for CPU because we have very limited number of CPU cores. Like in our normal computer, we have core like 4 or 8, 12 kind of core, 16 kind of core, 10 cores. This kind of cores are available in our normal computer. We are not talking about supercomputers. We are talking about our normal computer, which is we using day to day. Okay, so these limited cores are there, and still we are getting this kind of performance. To and now the next point. Okay, so next point is the how we are getting this kind of performance. So I will just clear some part. So how we are getting this kind of output performance. So for that we are using TensorFlow, right? TensorFlow, then PyTorch. So basically TensorFlow, PyTorch, how they are these libraries are created. So they are using CPU level instruction sets in their library. So because of that, it can perform faster. And the core library that they are using is BLAS. You might be aware of, which is uh, linear algebra subsystem, basic linear algebra subsystem. That is the full form of this library. So what we are doing in this process is all matrix multiplication, right? So to perform a better matrix multiplication, we require certain kind of library that can do this kind of task. So for CPU, we are using Open Blast library. When we are using GPU, now the point is, what is the difference between CPU and GPU? So when we are using GPU, we have thousands of cores available in the setup, right? So these thousands of core, how it can give us better performance. So there is one limitation in CPU. I will erase this thing so that I can write something new. So in case of GPU, what is the difference? So in GPU, first in CPU, we have RAM as well as L1, L2, L3 cache memory. This is the only storage we have. Whereas in GPU, we have vGPU, right? vGPU size will be like 4 GB to nowadays you can find 192 GB of RAM, VRAM, VRAM of GPU. So this kind of RAM you can get, but this kind of RAM is quite costly. You can think of like 50 lakhs rupees for just this kind of RAM setup. 4 GB RAM you can get in tens of thousands of rupees. But the difference is this size. Here you have to transfer data from RAM to L1, L2 cache. This is create latency. Apart from that, the technology we are using, DDR5, the latest RAM technology that we are using is DDR5. Whereas in GPU, the latest technology is GDDR7. Because of that, you will have better bandwidth in GPU. So data transfer is quite faster compared to CPU because it has a more RAM, more data storing facility, as well as core like CUDA. When we are thinking of GPU in NVIDIA GPU, then it is CUDA core. They are called CUDA cores because they are using CUDA library to perform parallel activities, right? So here we have thousands of CUDA core. Maximum in the latest GPU, they have around 24,000 CUDA cores available in one GPU. So you can think of how much faster it can perform, right? So this is how it is executing. And because of that, you are getting more better result. And we are talking about very basic example. Now, if we go to the very complex high-end experiment, then there is another feature, another property comes into the picture, which is based on this two library, which is called mixed precision. Precision. So what is mixed precision? So you guys have heard about DeepSeek R1, right? So why DeepSeek R1 become suddenly quite popular? Because it can perform on low-end computer, low-end devices. Why? Because the data type. When we are writing any data in any language, we require certain type of data storing facility, like data types. So when we are processing using CPU and GPU, basically the data will be in form of floating points. So what is the size of floating point we are considering to store data? It can be 64-bit, it can be 32-bit, it can be 16, it can be 8, it can be integer 8. So this there are different type of data types in CPU as well as GPU. So using mixed precision, we can do two kind of thing. We can combine floating point 64-bit kind of data with 32-bit kind of data. So we are combining two different type of data to process the image so that we can get better performance. So nowadays they are using mixed precision to deploy to get faster response. And here we are not talking about anything like transformer or different neural network model. Okay, we are just purely talking about simple, very basic convolution neural network. So this is how it is executing. Now, if you have any query related to the CPU GPU setup, how it is, how the convolution neural network or neural network is implemented using CPU and GPU on our classical computer, then you can ask. No question? Okay, so we will move to the next part, that is the our quantum computer. Now the big thing. So what is first? I will start with what is quantum computer. Everybody knows that it is qubit kind of setup which can be in a multi state. Like it can be in the state zero as well as one simultaneously, right? That is the feature of quantum computer. But why, why that is not the main core part of this thing. Apart from qubit, we have superposition and entanglement and interference. These are also the part of the quantum computer, that why we are using it, why what quantum computer is and why it is needed. So basically we wanted to perform certain tasks, like uh, let's take this example, drug discovery, which is just suddenly sometimes before an IBM company has run some deep learning model to for drug discovery. So to process this thing, our classical computer will take too much time. So to reduce that time, we are using this quantum-based setup. Here we have, and how it is making faster. So in GPU, as we know, in GPU we have around 24,000 CUDA cores. Then what is the difference? Normally, when you have heard quantum computer, then it will be like 100 qubit computer or 128-bit qubit computer, like, so it is only 100 bit. So what is the difference? We have this many core. So what is the difference? How it is better? So you can get exponential performance when we are talking about qubits and cores. In the core, what you are performing is basically bit data, but sequentially. Whereas in qubit, what we are doing, we can perform data, but because of the property of superposition, we can uh, set the qubit in the zero as well as low or high state simultaneously. Because of that, we can process data simultaneously for multiple bits. For 100 bits, not exactly 100 bit, they are able to use it because of current scenario of errors generation, and because of that, we are not able to exactly utilize all 100 bits qubits, but still we can assume, like, let's take simple example. Suppose in our computer we have 3-bit data, 3-bit, right? So 3-bit is 2 raised to 3, that is total 8 states are there. So we can, like, assume, like, we can see like how many different state we have, right? Correct. So 100, 10, 11, 111. So computer requires sequentially process this data. Suppose it has multiple CPU, multiple core, then it can process parallelly. No doubt, parallelly it can process, but it require more than one process, one sequence is required. Whereas in qubit, just Q1, Q2, and Q3, it can be in this state simultaneously and using entanglement. Here you can see entanglement. Entanglement is like dependency. Suppose right now, if I wanted to get this data, like 3, right? Sorry, 3, it's not 3, it is 2. Then I have to set this bit 0, and this bit 1. So it is uh, create interconnection or dependency. It will create dependency, and using that you can get this particular state. So that is entanglement. And creating this state, simultaneous state, it is called superposition. And to get this perfect state, like I want to get 2, then I have to give certain sort of input from the outside. So that is the interference. So using this, we are uh, creating quantum computer. So not just qubit, but this part is also important. And how it is creating superposition, that is basically next level of thing, that is in the form you can call it is a wave function. So wave function is not like this kind of wave, but it is a mathematical equation which is called wave function. Okay, so what wave function, this actually this came from that wave particle duality, like duality. It is came from this term, because wave particle duality, which provides atom. Because here we are, when we are working with quantum computer, it depends. It works with quantum mechanics, which is like studying the behavior of matter and energy on atomic level, right? So one, when we are talking about quantum computer or quantum mechanics, we are talking about atoms. So we are when wave particle duality is like we are checking the state of atom, not we are checking, but the atom is in a state of particle as well as wave until we are observing that state. So it is quite complex, but you might have heard the Schrodinger's cat, right? So that is basically one of the example of explanation of how it is implemented. Like that cat is in a box, but with the cat there is atom, which is radioactive atom, and that atom is sealed in box with the cat. So if that atom is leaking the radioactive the radiation, then cat will die. But we, the box is closed, we don't know that radiation is decaying or it is radiating. We don't know the state of uh, inside the box. So that is why the cat is alive and dead at the same time, just like the qubits is 0 and 1 at the same time. The similar this concept is coming from wave particle duality. So we do until we observe, until we open the box, we don't know cat is alive or dead. So wave particle duality is a particle, that is atom, which can be electron, photon, that kind of thing. It is in this state which is measured. Until it is measured, it will be in the wave form or particle form. To give you more idea, I can open one video link, but I think we have to consider time also. So if we have time later on, I will uh, play that video. That video is quite good to explain how this thing works. Okay, so right now you can understand what qubit is, superposition is, entanglement is, in interferences. Okay, so this is how this thing is working. And to represent the state like 0 and 1 at the same time, right? So when we are talking about quantum mechanics, it is based on randomness, it is based on probability. So to represent the equation, which is in the form of psi, like this, it is then alpha, then zeros probability and amplitude with beta, that is the amplitude of 1 and 0. So this is how we are measuring the probability of the qubit, single qubit, based on the value. When so the state is like when we measure, we will get the definite output. So until we measure the qubit state, it will be either in the 0 or 1, so that we can check all this different state. But when we measure, it will be in a classical state, which is discrete, what I can say, definitive state. So either it will be 0 or 1, it will be fixed when we are going to measure the qubit. So this is how it will work. And the answer will depend upon this equation. So until you measure, either it will be like 70% 0 and 30% 1. This kind of thing scenario is also possible until it is measured. And after, depending upon the amplitude, it will be decided either 0 or 1. That will be the result, last result. So this is how it is measured. And uh, as we know, in our normal computer, we can see different uh, every day we can see different kind of CPU came into the market. You can take Snapdragon, or you can say take MediaTek, Intel, or any other platform. They all are creating different microchip based on silicon. We are using transistor. Using transistor, we are creating gates, and using gates, we are creating certain part like arithmetic logical unit, core, or internal cache memory. These kind of things we are creating using gates, right? But in case of quantum computer, everybody is trying to create their own way to create quantum computer. Like Google is using superconducting material to create the quantum computer. Same as IBM. IBM is also using superconductive material to create quantum computer. So here, these are some of the type of quantum computer. Like I think qubits they are using is superconducting material. If they are using superconducting material, then they have to create an environment which is like uh, cryogenic environment, which is near 0 Kelvin temperature, right? So to create superconducting situation, we require this kind of environment. And when we create this kind of environment, it it may possible like outer environment will affect your result. So that is decoherence. It will, I will talk about that later. But this is one type. Then there is another type, trapped ion qubit, in which we are changing the number of electron. Based on that, it will be considered as a high or low. In superconductive material, it will be 0 and 1. When we are considering trapped ion qubit, it will be either down or up. This there is photonic qubits. So for photonic qubits, we don't require a cryogenic environment. It can operate in normal environment also. It is also implemented with photonic qubits, but for photonic qubits, we to manage each and every single photon particle and using and to implement entanglement using photonic photons, it is quite difficult. To there are also certain kind of error generation in that part also. So in photonic qubit, it is also there. Then Microsoft, they are using topological qubits. Their marijuana, I don't know, I just forgot the name. So they are using topological qubit, which is also based on superconducting material. So they are also using this kind cryogenic kind of environment to manage the quantum environment to perform the task with less error. Because till 20, August 2020, 2025, they are still trying to doing the working on reducing the error. So right now, the most important part in the quantum computer is like how to reduce the error, and we can use quantum computer to do all kind of things like using like normal computer. Right now, what we are doing is we are combining normal classical computer with quantum computer to perform quantum based analysis. But to perform separately, like it has its own, like when we are considering CPU plus GPU system. So GPU without CPU, GPU can't work because CPU is giving the data. CPU is directing the GPU to perform the task. So it is currently this kind of scenario is that CPU plus quantum computer. This is our QPU, and something like that is given. Name is given QPU. So this is how currently working with hybrid approaches they are applying to even perform all kind of tasks which include AI, cybersecurity optimization, or drug discovery, or you can take anything. So using all these things, mainly the AI part is very initial state because of a number of qubits that we can use simultaneously compared to GPU, but still you can get faster response compared to GPU. Then after optimization. So optimization is basically used when you already have established some certain setup and you wanted to test different variables, different scenarios. Then you can utilize quantum computing to identify certain scenarios. Okay, so that is why we are using optimization. And the most and dangerous and scenario is the cybersecurity, because uh, cybersecurity is the most important part when it comes to the quantum computing. Because let's take a scenario when AI came into the market, everybody was afraid that it will take people's job, right? It not only job, it can even destroy someone's life, because if we are creating certain videos or images that can disturb someone's life, it can be harmful to individual also, right? But in case of quantum computer, it can destroy a country. Why? Because cybersecurity is the essential part. Currently, what cryptography we are using is based on our classical computer. So if we are trying to hack or decrypt the password using a classical computer, it will still take some year to crack that password. But when we are considering the classical level of cryptography and we apply to the quantum computer, it can break in seconds. So that is the biggest what I can say scenario that can harm even the country also. So whoever is able to first create the quantum computer, they can become the superpower also. I can say like that also. So this is the main scenario. So with cybersecurity, with cryptography breaking, this decoding or hacking kind of thing will occur. At the same time, quantum security will also come. So that I don't know when it will come, or it is already there. I don't know. So this is also the one of the scenario that is that we have to look after, because right now America and China, they are in the they are the highest developer in this field. They are also investing billions of dollars in to develop their own quantum computer, because using that they can do so many different things. That is why they are developing in that direction. Okay, so this is the basic idea of quantum computer. And then after the main, that scenario that I was talking about, that is the hybrid approach. So the hybrid approach is basically uh, quantum computer, as I told you, that it can't perform certain tasks. So basically, it can handle the specific tasks such as evaluation, quantum wave function, and these all things. But to give data processing, how we can include classical component, that is classical computer. So it will give pre-processed data that we will be using for AI. Okay. Then after optimization, after the training epoch, the out result will be given to the classical computer. It will optimize, it will remove the error, it will give back to the quantum computer. It will again train the data. So this is how we can we will correct our data. Same way, this is for error correction. So this is how we are incorporating classical component in the quantum computer, because these things are still quite difficult to implement. That is why we are including classical components. Okay, then here you can see the kind of system works in feedback loop. Classical computer send instruction to quantum computer and receive measured outcome, and based on the result, often optimize the algorithm to improve the efficiency. So this is how we are applying this condition. And suppose we wanted to compare with our classical computer. So what is the difference? So as I told you, in our CPU, we are using transistor. So using transistor, we are creating gates, logical gates, which will create and or nor kind of gates, right? And using those gates, we are creating arithmetical logical unit, different cores, different L1, L2, L3 cache. We are creating all these things using transistor. Whereas in QPU, which is the quantum processing unit, we only have qubit, and which is, I think, in our computer we are using silicon, and qubit we are using niobium kind of I think superconductive material to create qubits. And using qubits we are creating quantum gates. Just like logic gates, we are using quantum gates, and through the quantum gates we are using classical component, and future I will show you, as well as data storage. In a normal traditional computer, we are using RAM for data storage, as well as hard drive or SSD to store the data. Whereas when we are processing, then we only require RAM. In case of qubit, we are using qubit. Sorry, in case of quantum computer, we are using qubit to store the data, because itself can store data in form of 0 or 1, and it can process on qubit using quantum gates. So this is how the storage issue is resolved, because CPU to RAM, their communication will occur. It will create latency even for GPU also, GPU and VRAM, the same thing will happen. So that part is I completely remove in case of qubit. Okay. Then after operating environment, so our computer can be operated in normal environment, whereas in case of quantum computer, it requires certain environment. As for the control and input output, in our computer we can use keyboard mouse to
বান্তে
give
আমি
input.
আজকে ওই পার দিকে
Whereas in case of quantum computer, we have to use normal computer like classical computer to generate input, and certain kind of equipment will be used to convert that input into microwave and or laser. It will be converted into this form, and then after it will be fed to the quantum gates, and that quantum gates will give data to, sorry, qubit. So this is how it will process. And the scalability. So scalability, when we are thinking of a number of computer adding into the single network and creating cluster, so you will get certain level of scalability. But whereas in case of quantum, you will have exponential scalability, because just by adding, you are using a 10 qubit uh, quantum computer, just changing to 12 qubit, you will get, see, 2 raised to 12 instead of 2 raised to 10. So you will get higher, better performance just by just adding 2 qubits. You can get exponential result. So this is the difference between these two computer. And using this difference, we are trying to approach like how we are going to approach AI in this direction. So in the in the as previous I told you, like in classical computer, we are using GPU to perform parallelization, using which we are implementing different algorithms like RNN, CNN kind of transformer. This is also type of RNN, right? So we are applying different methods, different algorithms using some framework like TensorFlow and PyTorch. Similarly, when we wanted to do something training kind of thing, training on a quantum computer, then what will happen? We have to use algorithm which is compatible with the uh, only with the quantum computer. So here one of the method is the variational quantum eigensolver. So variation eigensolver, this method is basically select the lowest eigenvalue from the matrix. So our image will be in the form of matrix. So it will identify the lowest value eigenvalue and it will give as an input. It will give as an output. But to provide this algorithm, we have to provide in certain way. So for that purpose, we are using quantum gates to process the data, and it will be fed as a input to the quantum bit, and then after it will give us the output in the form of eigenvalue. Okay, so this is how it is applied, and this method is basically done. I think in 2000, in this year, IBM has used VQE for on superconductive. They are using superconductive qubit, so to optimize molecular representation of drug discovery. So basically, it is a kind of AI based model. So how they are using it is mentioned over here. Neural network for vision-based neural network of optimization purpose, which is optimizing the hyperparameters. Okay, so this is how it is implemented. Second is the quantum approach, approximate optimization algorithm. This method is basically like k-means clustering, right? So the similar approach, like as I told you, when we wanted to apply a neural network in certain way, then we have to modify our model because we are using mathematical equation. So certain model requires certain kind of architecture of the model. So this similarly, when we are applying different application, we are trying to deploy different application. We require different approach. So this is one of the approach which is used basically for cluster level implementation. So here we can select feature where it can be used. Here you can see all these things. So in it was deployed by Atom Computing. I think they have deployed this thing and they have implemented for recommendation system this algorithm. Then after most famous quantum machine learning algorithm. So using quantum machine learning algorithm, what we are doing is we are creating SVM and then neural network kind of things. And for SVM, we are using uh, quantum kernel estimation. For NN, we are using QNN as well as QRL. As well as variational quantum classifier is also used for neural network. For SVM, we are using this thing. Okay, this is how we are using it. And I will talk about we have very limited time, so I will skip that other part. So I will just give you a brief idea how we can implement same experiment on quantum computer. So
Sir,
before we
excuse
can,
me, sir. Sir,
yes,
actually, what happened? Our schedule next speaker is waiting. So, how long
okay,
your presentation will? How
okay,
long
I
it
will
will take?
complete just this slide and then after we can conclude the session.
Okay, okay. We will take only one
It will
one
take
question.
maximum 2 minutes. Okay, yeah,
Okay, okay.
sure.
Okay, then we will take only one query or interaction with the
Sure,
participant. Okay, sir.
sure. Okay. So, everyone, so here, what is the issue? Here, whenever we are trying to approach this method in AI, so the problem is how we can implement it using different scenarios. So here we have to approach certain way. So first of all, here we are going with hybrid approach. Here we have data in this size, as we know, but to process all these things, we don't have that much of qubits available practically. So here you can see either we have 10 to 20 qubits available for practical usage, right? So we have to reduce the data size. So for first, data processing will come. This will be done by classical computer. It will process the data. It will reduce the size. Here you can see what it will do. Our computer will downsample the data. It will convert into when we are processing with our classical computer, we are normalizing the data. Here we are converting into the binarization. So it will convert into 0 and 1 because our qubit can store only 0 and 1. Then after, how we are giving the data. So batch handling, that is also done by the classical computer. So after doing that, the data will be sent to the our uh, uh, quantum computer. That quantum computer will load the data in the quantum state using quantum gate, and that data will be stored using the probability. So how it will be stored? So here you can see, suppose there are some pixels. This kind of pixels are there, right? So this kind of pixel will be stored as a this equation. As I told you previously, that what equation we are using, so that this is the psi. You can see this is the probability of 2 bits, because here we have 4 data, that is 2 raised to 2. There are 4 probabilities, so we have 4 probabilities, and this 0 0 is 2 qubit. So we are also applying entanglement. Okay, 0 1 1 0 and 1 1. There are 4 probabilities, and we are applying entanglement also, and based on this amplitude, we are getting certain kind of output. That data will be processed using QCNN as well as VQC. VQC we have seen earlier over here, right? So we will apply this thing to and will process the data sequentially. Here we will process data sequentially. Then after the processed data will be measured. So measuring come when, as I told you, the data will be in this state until it is measured, right? In superposition state. So first we will measure the data, so we will get the definite state, either 0 or 1. Then after that, data will again feed back to the classical computer. So here we will have certain what I say, certain algorithms that will try to extract data from the the quantum bits. So this is how this whole process will execute. And in this process, so many things will happen that I'm right now, due to the timing, I'm skipping, but so many things will occur, like how different classical algorithm is applied, what kind of output is received, how, and to receive this output, what kind of different process we have to to do on the classical computer. So there are so many things will happen in between this and data encoding, model processing, and measurement. So many things will happen, but due to the limitation of number of qubits, it is we have to downsample 128 by 28 image into either 4 by 4 image or 8 by 8 image. So this is how we are reducing the downsampling the image, so that we can directly use 4-bit qubit data. Here we can see this 4 qubit is basically, we are using it this way. We are converting this image from 128 by 28 to 4 by 4 or 8 by 8. So this is how we are getting this pixel value. Okay, now we any query related to this, you can ask.
Participants, do you have any question to ask?
Sir,
Mr.
I have a question.
Yes.
Yeah, please. We for this session, we only can take one question
Yes, sir.
because
Yes,
we
sir.
are almost out of time. So please hurry up, ask your question.
Yes, sir. Sir, I
Can
want
you
to
can
ask
you can you can you tell me what's your name, sir?
Rushikesh,
My,
myself, Rushikesh Jadhav.
Pardon?
Rushikesh.
Rishikesh Yadav. Okay.
Yeah.
Okay,
Yes, sir.
okay,
I
sir,
want to
please
ask.
ask the question.
So with
Hello.
respect, hello.
Hello,
Yes, sir,
hello,
please ask the
Chaitra.
question.
Okay. With respect to QML, quantum ML, and quantum AI, are there different approaches to encoding the data before feeding the quantum network, or they are same?
No, it will be different because as I told you, depending upon the data type, we have to approach different way. We have to apply different algorithm. So that is why in under QML, you can see under QML, we have this quantum kernel estimation, quantum reinforcement learning, QNN, and variational quantum classifier, as well as QCNN. This is also under QML. So we are creating different algorithm for different approach. So this is how we are implementing AI or machine learning with quantum computer.
Thank you, sir.
Okay, that's all for this session. Mr.
Okay, if
Bhavindarji,
you
thank.
okay, just a minute, sir. Suppose you have any other query, this is my mail ID is written over here, bhavin@edutechlearning.com. You can drop me a mail. I will reply on that your query. So that is also another option. So you can note down my mail ID.
Thank you so much, sir, for sharing such an insightful lecture with us. Thank you, Mr. Bhavindarji. We are now closing this session, and participants are requested to join to the next session, that is the session 4. Link is already being shared through your mail ID as well as in the WhatsApp group. Please join.